equilibrium, ideal systems of rigid bodies. Virtual work. We now extend the principle of virtual work to the equilibrium of an interconnected system of rigid bodies. Our treatment here will be limited to so-called ideal systems. These are systems composed of two or more rigid members composite of two or more rigid members linked together by mechanical connections which are incapable of absorbing energy through elongation or compression. And in which friction is small enough to be neglected. Is small enough to be neglected. For an example and more description, consider this picture in the next. In the part A, show a simple example of an ideal system. Where relative motion between its two parts is possible and where the equilibrium position is determined by the applied external force P and F as shown in the picture. We can identify three types of force which act such as interconnected system. One, active forces. Are external force capable of doing virtual work during possible virtual displacement. Force P and F are active forces in this picture. Force P and F. Force P and F are active forces because they would do work as the links move. The links and part category 2 reactive forces. Are external forces capable of doing virtual work? During possible virtual displacement. In the picture provided here, excuse me, it is for previous and reactive. Reactive force are different. Reactive force are forces which act at fixed support position. At fixed support position. Where no virtual displacement take place in the direction of the force. Reactive force do no work during a virtual displacement. No work during virtual In this picture, the horizontal force Fb, as shown here, exerted on the ruler end of the member by the virtual guide can do no work because there can be no horizontal displacement of the ruler. The reactive, this ruler, it means, because we have a reactive force here, and because we don't have any horizontal displacement in this ruler, there is no work here. The reactive force F0 exerted on the system by the fixed support at O also does not work because O cannot move. The forces in this point shown here and the reactive forces. Internal forces is the next categories. Three. Internal forces. Are forces in the connections between members during any possible movement of the system or its parts movement of the system or its parts the network done by the internal forces at the connection is 0. This is so because the internal forces always exist in pairs of equal and opposite forces, as indicated for internal forces Fa and minus Fa here. At joint A. The work of one force therefore necessarily cancels the work of the other force during their identical displacement.